5. To determine the accuracy of a measurement, we look at the number of significant figures, okay? Now this significant figure again tells you the accuracy. It doesn't necessarily tell you the values of the problem. So here are the rules for determining significant figures. The first rule is all non-zero significant digits. The first rule is all non-zero digits are significant. What are non-zero? Numbers that are not zero, which is 1 all the way to 9. So all those number 1 through 9 will be significant. The second rule gets a little bit tricky, is that if you have a number smaller than 1, then we look for the first non-zero, and we're going to continue counting all the following digits, because all the following digits are significant. For example, we have this number right here. The first non-zero is 1, okay? And all the following digits will be significant as well, which give us a total of 4 sig fig. Over here, we have, this is the first one, followed by 5 number. So that's why we have 6 significant figures. Now we get a little bit more complicated when the number is larger or equal to 1, okay? Now, when the number is larger or equal to 1, what do we look for? We look for a decimal point. For examples, if we have a decimal point, all the digits are significant. Isn't that easy? Here we have 1,000, and with a decimal point, all of these are significant figures. So therefore it has 4 significant figures. Right here you have a decimal, and we're going to count all of them. That will give us 5 significant figures. Now where we don't have a decimal point, it becomes a little more tricky. This is the hardest part of the problem. In this case, it's called when you have a large number that doesn't have a decimal. So what do? We're looking at the non-zero, which is going back to rule 1, and we're looking for any zeros between 2 non-zero. For instance, we have right here 1, 2, 0, 0. This are significant. 1, 2 is significant because they are non-zero digit, whereas this 2, 0 are not significant because they are not between 2 non-zero. Right here we have 1, 2 is significant. 0, 0, 5. We have 5 significant figures because this 2, 0 is between the 2 non-zero. Here we have a very large number, but if we look closely at the rules, this 0 are not significant figure, and the only 2 that are significant figures are the 2, 0 between the 2 and 5, which is between 2 non-zero. Now, if we were to say that these are not significant figures, does that mean we can eliminate the 0? When you have a number that's larger than 1 and it's being replaced by 0, those 0 are not just ordinary 0, it's now a placeholder. A placeholder basically are zeros, okay, that represent the values of the number. For instance, if we were to take out this 0, what happened to the number? Now it's only 12,000. If this were money, you would lose a lot of money. Because if you add back the 0, what you have is 12 millions, okay? So know the difference between placeholder and significant figure 0. And one last rule is when you have a number that's based on counting. I mean, you literally count it. For instance, you count there are 5 atoms, 5 apples in a basket, 9 pencils, and 3 lines. This number has an infinite number of significant figures, so they don't affect your calculation at all. What about when we have scientific notation? The only part that's count for significant figure is